Let's take a look at the practice questions for sine, cosine, and tangent, these trig functions. Question number 1 says the base of a right triangle is 8 inches and the height is 10 inches. So our triangle is given as it is described, and we're looking for the measure of angle x. There's different trig functions that we can use to find x, but our answer is going to be based on what we're given here. Using the side lengths of 8 and 10, we could find the hypotenuse if we needed to using the Pythagorean theorem. But let's go ahead and look at some of the choices we have here. So the first choice, we're just going to look at our answer choices. It is a which question, so that does tell us that we're going to evaluate the answer choices to see which one is correct. The first choice makes use of sine, and if you'll remember, our sine function is equal to opposite over hypotenuse. And they say that the sine is equal to 8 over 10. Well, our opposite side length is 8, but our hypotenuse right now is unknown. It is not this 10. It's going to be larger than 10 because we also know that when we have a right triangle, our hypotenuse is the largest side. So this answer choice is out. This gives the sine the opposite over hypotenuse. They give us the 10 again. That is incorrect. We know that we're not using that. Now, what about tangent? That comes in with answer choice C. Tangent is opposite over adjacent, and you've got to know these relationships, these definitions of these trig functions. So tangent, opposite, again, is 8, and our adjacent side length is 10. So that would make 8 over 10 correct. And that would make answer choice C the one we're going to use. That is the correct answer for this one, answer choice C. Again, if you'll notice, just looking at the others just for our learning purposes, here they did the opposite, the reciprocal. They did 10 over 8. And then they also made use of cosine, and the cosine is adjacent over hypotenuse. Again, they tried to use this 8 over 10. And that's not going to be correct either. So again, number 1 is answer choice C. Question 2, if the angle of elevation to the top of a 100 feet tall building is 47 degrees from point C, how many feet is point C from the base A? So we've got to see what all are we given and what do we need to find. So we're given this 100 feet tall building. We've got that labeled here. This angle of elevation, remember, angle of elevation is relative to the horizontal. So we're looking up from point C up. That's going to make this our 47-degree angle that they're talking about. And they want to know how many feet is point C from the base of A. So we're talking about this length here that we're looking for. This is our unknown x. You can think in terms of this triangle right here. This is 100, and we have an angle measure of 47, and we're looking for x. When we look at our answer choices, we see that they are making use of some of the trig functions, and we're looking for our unknown side length here. So what relationship, given an angle measure of 47, we have our opposite side length of 100, and we're looking for our adjacent side length of x. Given those unknowns, what do we use with opposite and adjacent? Opposite and adjacent is tangent. Tangent of x equals opposite over adjacent. So let's plug in what we know and what we're looking for. Our x value is our angle measure. So tangent 47 is equal to our opposite length 100 over our unknown x. And we're trying to solve for x. So we'll multiply through both sides by x, and then we'll divide through by tangent 47. And we get that x is equal to 100 divided by tangent 47, which is answer choice H. Number 3 says, for all x such that 0 less than or equal to x less than equal to 90, which of the following expressions is not equal to cosine of x? So here's what we're talking about. When we're thinking about a quadrant, and from 0 to 90 degrees, we're talking about quadrant 1. If we were to draw our unit circle, we're talking about here quadrant 1. That's where we're talking about. Okay, so we want to know which of the following expressions is not equal to cosine x. So we've got a few things to it, we've got to evaluate each one of these to see what we're talking about here. But let's just make something known here. When we're finding any kind of cosine x, remember, what is the sign of cosine x in the first quadrant? Remember, we have a saying, all students take calculus. That's one of the sayings. That's the one I know. I know there's a couple of others. But what this means is cosine is positive in quadrant 1. Positive in quadrant 1. So that's one thing we could be looking at is the sign. We could be looking at the sign where it's not equal. This choice A sort of looks like it may be a little difficult, but let's do a little simplifying under this radical. 1 minus sine x squared is the same as cosine squared. And the square root of cosine squared is just cosine. So yes, this comes out to be cosine x, which is the same as cosine x. So this is equivalent, but we're looking for what is not. So A choice is out. The next thing that I would probably take a look at, if we look at cosine of a negative x. So let's just think about this. What this means is if we're looking for cosine of x, let's just say x is equal to 30. Cosine of 30 compared to cosine of a negative 30. Okay, cosine of positive 30 is going to be up here somewhere, and cosine of negative 30 is down here. And we know the values of that. We can do it, but we really don't even have to think about that. Let's think about the signs. All students take calculus. Cosine is also positive in the fourth quadrant. Our reference angles are the same, so this is also going to be equal to cosine of x. Same thing here. So we're looking for the not, so that one's out. Well, look at C, a negative of what we had in B choice. Well, that would give us a negative cosine x. It's going to give us a negative because of the sign out in front here. That's going to change it. That's not equal to cosine x. It's equal to a negative cosine x. So C is actually our choice. If we wanted to look at the other options we have here, sine of 90 minus x, again, if we're using x to be 30, and if we look at sine of 90 minus 30, that's sine of 60. Sine of 60 is equal to cosine of 30, which is what we started with. And if you use your unit circle, your values that you know from that, or you could plug that into your calculator and find the value. Those are the same, so that makes it invalid because we're looking for the not. And a negative sine of x minus 90. So again, let's look at, we're talking about a minus sine. We used x to be 30. 30 minus 90 is a minus 60. And so we were looking at the cosine 30. If we say a minus 60, we're looking at the sign, the negative sign. That is also equal to the same thing as cosine 30. Prove it to yourself, plug it into the calculator, and you would see that. So again, we wouldn't even have to go through choices D and E after you had found choice C to be the correct answer, but I just wanted to walk through that for you for learning purposes again. Now let's look at question number 4. Quadrilateral ABCD is shown in the figure below with the lengths of the 4 sides given in feet. The measure of angle C is 90. What is sine of A? So we're looking for sine of this angle measure. So we have a quadrilateral. Notice, again, this is a question that will tell us not all quadrilaterals do we automatically have a rectangle. This is just a quadrilateral, means a 4-sided figure. So I've got to figure out how I can make use of the side lengths to find what sine of A is equal to. We have side lengths here that were given in our choices. Let's remind ourselves though, what is sine equal to relative to opposite and hypotenuse and adjacent? Sine is equal to opposite over hypotenuse. Well, that's of a right triangle. And we don't have a right triangle right here. We have just this angle measure. But we could possibly look at making a right triangle. Let's play around, but let's see what happens when we draw this line length right here to connect between B and D. When we do that, and we can see that we've made a 3, 4, 5. That is a Pythagorean triple right here of this triangle right here, a 3, 4, 5. So that would make that length 5. Now we can find the sine using this definition if we have a right triangle. How do we know if we have a right triangle? Well, the way that we can know, it's kind of in a backwards way, but if we do look at this triangle, the 5, 12, 13, we can look at these side lengths and know that a 5, 12, 13 is a Pythagorean triple, meaning you have to have a 90-degree angle, and it's going to be that angle right there with our two side lengths of 5 and 12 and our hypotenuse of 13. So we had to be familiar with this 3, 4, 5 Pythagorean triple and the 5, 12, 13. That's how we will know this is a right angle, and then we can make use of knowing what is the opposite and hypotenuse. So opposite of x is side length 5, and the hypotenuse is 13. So 5 over 13 gives us the sine of x, which is answer choice G.